Okay, so we have already talked about the graphs of sine and cosine, and we'll continue to talk about the graph of other trigonometric functions, including tangent, cotangent, secant, cosecant. Okay, so now we want you to graph the y equal to tangent x. So as before, we wanted to use special values, special angles here, to find a bunch of points here. But we also need to remind you the tangent f negative x equal to negative tangent x is odd function. What means odd is symmetric to origin. So this is why we only choose the special values from 0 to pi over 2, because from negative pi over 2 to 0, you can use symmetry to draw the graph. Okay, so after you plug in all these points, this is from 0 to pi over 2. Okay, and be careful, is tangent of pi over 2 is undefined. Why this is undefined? It actually goes to infinity. Okay, so so in chord algebra, what is this dotted line called? If it approaches pi over 2, and then the y value goes to y value goes to infinity, this is called vertical asymptote. Yeah, okay, and then you use the property of symmetry. You can draw the part from negative pi over 2 to 0. And similarly, and this one is also called vertical asymptote, because its approach negative pi over 2, but y goes to negative infinity here. Okay, and so the period of the pi, the tangent x is pi. So what does this mean, the period? So it will repeat, yeah. So so this will be the picture of tangent x for a lot of more pictures here. Okay, so this is this thing. Okay, so what do you know about the tangent x? The period is pi, and the domain. What will be the domain? Is all real number except the odd number or multiples of 2. Okay, so where is the domain? If I were you, I will okay, so combine these two things together, yeah. The vertical system, vertical asymptotes, and the domain. Okay, so what will be the vertical asymptotes? Is all the multiples of the pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, all these things. Then what will be the domain? Domain will be all the values such that you could accept for these things. So vertical asymptotes and the domain, you can always remember these two things together. So it's very important. So what is not in the domain? It is your vertical asymptotes, yeah. Okay. So x-intercepts. So x-intercept between each of the asymptotes, but it's also what? It's, let's say, it's pi, 2 pi, so it's what? K times what? Pi. Yeah, so k here is plus or minus k pi. K here can be 0, 1, 2, yeah. And it's odd function with what? Or with origin symmetry, yeah. So odd function, it is symmetric to origin here. Okay, so I also wanted you to pay attention to one thing. Okay, so this is the period. So this is one period, yeah. Okay, so this is a half. From here to here is a half. Okay, so from middle again is what? Pi over 2 divided by 2 divided by 2 here is what? Pi over 4. It's pi over 4. And what is tangent pi over 4? This is equal to what? 1. Okay, so this is a very important, property, because later on when we, graph the variations of tangent x, we do need to pay attention to this point. It's just like, the amplitude for sine and cosine. This is one of the special point that you need to pay attention for tangent and what? Cotangent function. Okay, so now let's look at this. So graphing A tangent B x minus C. Okay, so b bigger than 0. Okay, so as before, so here is, this is like amplitude, this one or amplitude. Okay, so it's not really amplitude. Okay, I call it amplitude. I will explain to you later. And these things were related with what? Your period, the B. And the C is related with your what? Shift. Yeah, so shift. Okay. Okay. So all these things, and so you can look at all these details here, but I will introduce you a shortcut how to draw the pictures. Okay, shortcut how to draw the pictures. So let's look at the example. Y equal to what? 3 tangent 2x. So A equal to 3. That will be, amplitude. Okay, I will explain to you why. So what will be the period? Period is what? Not pi divided by b anymore. So it's not pi divided by b anymore. Okay, they didn't say it here either. Okay, so not 2 pi divided by b anymore, because for sine and cosine is what? 2 pi period. But for tangent and cotangent, what is the period? It's pi. So it's pi divided by b. So pi divided by 2. Okay, so for pi divided by 2 here. Okay, so now how could I sketch the graph? Okay, so they have a lot of steps, but for me, I will introduce you an easier one. Okay, so 3 tangent to x. So it's tangent, yeah. So what is the period? Pi over 2. One thing you need to remember. So this is pi over 2. Is this pi here pi over 2? No, this is the biggest common error. So because for tangent, it has what? 2 parts, yeah? So it goes through the 0 here. Okay. And this one goes to infinity. Here is go to negative infinity. So here is not the whole period. This number here is what? Pi over 2 divided by 2. So it's what? Pi over 4. And here is what? Negative pi over 4. Are you with me? So this is the first thing that you need to do. So here, the end point here, the end here is what? So your period, pi over 2 divided by 2 is pi over 4. So is the value here is the period divided by 2 to get you here. Okay. So the next thing, how could we get the amplitude? Okay. So amplitude is not called amplitude. Okay. So where does this number come from? Okay. So you look at from 0 to pi over 4. Do you remember that I emphasize? When you look at from here to here, in the middle, so 0 to pi over 2, in the middle is what? Pi over 4. Tangent pi over 4 equal to 1. Okay, so now, so what will you do? You look at here, from 0 to pi over 4. What's in the middle? what is a half of pi over 4? Is what? Pi over 8. Okay, pi over 8. Okay, and if we only have tangent, what is the corresponding value here? 1. Yeah, if we only have tangent. Now, you have a 3 multiply here. What will you have? 3. Okay, similarly, you will have here negative pi over 8. Then what will be the corresponding here? Negative 3. Okay, so that will be the picture here. Are you with me? And if you wanted to draw the picture, okay, draw the picture for between negative pi over 4 to 3 pi over 4, what will you do? You draw one more. Are you with me? That will be done. Okay, so this is the technique that I wanted you guys to use here. Okay, so so you can practice following the instructions in the textbook, and or you can use a shortcut that I just introduced for you to sketch. Okay, great. So it's the same thing here. Yeah, so when you see here, when you see here, when you see here, when you see here, yeah, so this is where the 3 come from. Okay, so my sketch is I'm not a good artist. Okay, so the graph it much better here. Okay, so similarly, y equal to cotangent x is like this. You can use special values, but what should you be careful here? Because cotangent of 0, which will be what? Cosine of 0 over sine of 0. Yeah, what is cosine of 0? 1. What is sine of 0? 0. So cotangent 0 is what? I defined. And cotangent what? Pi over 2 is cosine of pi over 2 over sine pi over 2. So this is what? 0 over 1. This is also 0 here. You with me? So here, so for the cotangent, your 0, pi, 2 pi are what? Vertical asymptotes. And because it will go to what? Infinity or negative infinity at 0 at pi, and its x-intercept is pi over 2, 3 pi over 2, 5 pi over 2. Okay, so this is very, very important. So this is one of the things that you can differentiate tangent with cotangent. For tangent, it goes through 0 and goes up. For cotangent, it does not go through 0, so it's from 0 to what? Pi, and it's also what? Decreasing. And this one is what? Increasing here. In this interval, you cannot say that tangent x is increasing on the whole thing, because it does not. Okay, so we needed to mention here. Okay, so tangent x is increasing from what? Negative pi over 2 to pi over 2. But you cannot conclude tangent x is increasing negative infinity to infinity, because it's you have so many parts, it's repeat. Yeah, so okay, so this is what happens. Okay, so we will see cotangent x is decreasing from what? 0 to pi, but cotangent x is not decreasing on the whole thing, negative infinity to infinity. Okay, you cannot see that. Okay, so y equal to cotangent x and its characteristics. So vertical asymptote is at multiples of pi. That used to be what? X-intercepts of cotangent x, yeah? And x-intercept occurs between each pair of consecutive asymptotes. And so it is also an odd function. Okay, so it's also an odd function. And similarly, we will do cotangent bx minus c. Yeah, so all these things and all these things. So what I will do for you, we will do the same thing here. So we will see how could we graph y equal to a half cotangent pi over 2x. So what is your a? A half. What is your period? Remember, it's always what? Pi. It's not 2 pi anymore. It's pi divided pi over 2. So this is what? 2. So now what should we do now? So what I will do is I will draw cotangent x, yeah? Okay, so I've just forget about all the things. I will just draw cotangent. Remember, it's used to be what? From 0 to what? Pi. It used from 0 to pi. But this pi will be changed. Yeah? So cotangent. So it goes through here like this. Okay, I tried my best. Okay. Oh my god, this is too much. It's not even. Okay, so like this. Okay, so this is a cotangent. Okay, and where does this amplitude come from? So we were always what, like this is a half here. We will be 1/4 and what? 3/4. It's a half, another half, a half, another half. Okay, so this is where it corresponding to your amplitude. This is corresponding to your amplitude. And what is the period here? Is 2. It does not mean that you forget pi here. It does not have pi because you have a pi in the coefficient. That will be the picture. Then, how could you draw the rest of them? It's just, continue. So here it will be 4. And then similarly draw on the left. Okay, so what do you need to pay attention to? The amplitude come from where? 1/4 and 3/4. That will be corresponding to your what? Amplitude. Are you with me? So that's really, really important. Okay, so let's go to see. Okay, so we identify all these things midway. So that is what? X equal to 0 and x equal to 2. You can do that, yeah? Okay, and then you can find the points 1/4 and 3/4. So why do we want to find 1/4 and 3/4? This is corresponding to your what? Almost like we call it amplitude. It's not amplitude anymore, but we call it amplitude. Okay, so because that's similar to what? Sine and cosine. If you have a half in front, that will determine the amplitude. Okay, and then you draw the graph. Okay, and for the cosecant, the secant. Okay, so cosecant is what? 1 over sine. Secant is what? 1 over cosine. So even from the definition, what could you guess? How could you draw the cosecant and secant? I will draw sine and cosine first, and then draw the cosecant and secant. Okay. So the period of cosecant and secant, it will be the same as the period of the sine cosine. Okay, so the picture is right here. So cosecant, because it's 1 over, so when 1 over 0 goes to infinity, 1 over 0 is go to infinity, and 1 over 1 is 1. Yeah, so you can draw this, you will be able to draw the pictures. So it's like a U, big U's, yeah, on top of the sine. Okay, and similarly secant, it will be what, this is cosecant, yeah. So okay, so and similarly the secant will be the big U's on top of what, cosine x. Yeah, yeah, you can think about the vertical asymptotes and all these things. Yeah, okay, so this is cosecant and secant. Okay, so how could you draw the cosecant curve? Okay, cosecant curve. First, draw the sine, and then, so after you draw the sine, this, what means this plus pi over 4? Left pi over 4. Are you with me? This is sine left pi over 4. After you finish this, what will you do? Put u's on top. Put u's, on top. That is your cosecant. You with me? Put u's. Yeah, so it's pretty easy. Okay, so it's a lot of like work here, but actually the definition is pretty easy. You just draw the picture first, draw the sine and the cosine first. After you draw, put u's. Okay, so this is, now we make the graphs of all the trigonometric functions. So one thing you need to be careful, so y sine x, it goes from origin, goes up like this, yeah. Okay, so I also want you to remember what will be y negative sine x. It's flip over x-axis, yeah. So it is like this. Are you with me? So this thing will be what very important, if especially when you were asked to sketch the graph. Okay, so negative sine is always what, go from the origin down. Okay, and positive sine, it is what, go up. Are you with me? Okay, and similarly cosine is from the above. Okay, so what will be negative cosine? It's from the below. Okay, so this will be the most important thing here. And the tangent, it will be go through the origin, goes up. What will be the negative tangent, guys? Symmetric flip over x-axis. So it will be like this. So this is negative tangent. Cotangent is this, okay? So this is still negative pi over 2 to pi over 2. Are you with me? So what will be negative cotangent? Like this. Okay. This is pi. This is pi over 2. Okay. And you need to be super careful between tangent and negative to cotangent. So what will be the difference? This one goes through 0, and this one goes through what? Pi over 2. Okay, you guys need to be super careful. Okay, whether it's go through 0, it will be one tangent. Go through pi over 2, that will be cotangent. Okay, and it's very similar when you find a negative cotangent and the tangent. Okay, so these are these things. At the negative cosecant, it will be what, I will draw it here, it's too much. You with me? It will be what, flip over. Okay, flip over. And similarly, the negative secant, it will be, flip over. Okay, flip over. you guys use the same technique. Just be careful. Okay, so that's the sketch of the graphs.